I'll be honest, the answer has been staring us in the face for 15 years and we missed it. I'm really excited that it finally occurred to us as opposed to somebody else. All over the world, in every part of our lives, we have silica in many forms. The toothpaste that you use, electronics. I've seen it added to hamburger to make hamburger flow better. Fiber optics. If you want your tire to run longer and not fall apart, then they add silica to keep it cooler. They use it to polish silicon wafers to make them very flat. And that's a tens of thousands of tons a year process. But they all are built on the use of silicon metal. That's done by taking silica with carbon and treating it in an electric arc furnace at 3,000 degrees Fahrenheit. By producing silicon that way, you also, of course, produce carbon dioxide. It's a very expensive process. Obviously, it would be nice if you could figure out how to use other forms of silica to produce silicon-containing compounds without ever having to go to 3,000 degrees. We decided, gosh, why don't we try using antifreeze? And it worked. You can dissolve silica in antifreeze with a little bit of base, which we can recycle. And then after we dissolve it with the antifreeze, we replace the antifreeze with ethanol. That allows us to distill it to high purity, 99.99999% purity. So it can be used anywhere. Now we can use not only sand, but ag waste in the form of rice hull ash. The rice plant takes silica out of the ground and it puts it in the husk and it puts it in the stalk to reinforce them, to make them stronger. Plants don't pick up heavy metals, so the silica that's contained in any plant is relatively pure. A group of people have learned to burn the rice hulls for their fuel value. The byproduct is a silica-rich ash. Everywhere that they produce rice hull ash. That material is often landfilled. We're taking it away from being a negative to being a value-added product. It's a straightforward way to turn somebody else's straw into gold, if you will. Our goal at this moment is to scale to 50 kilos of distillable silica a month. The main obstacle is designing larger scale equipment. That's the next step. We've got it patented. We're dropping thousands of degrees in temperature. We're taking a waste product out of the environment. We save 6 tons of CO2 per ton of product. It's green, and everybody will want to say green science and green chemistry is incorporated in our product.